thank you to Gustavo Garcia, Rodrigo Navarre, and Carlos, and the entire committee behind organizing this symposium. I'm very honored to be here today, share with you some of the research that we've done at the University of Illinois at Urbana-Champaign, and some of the work that's already transitioned to the industry as a company called Reconstruct. So my talk today would focus on two topics: how we can take advantage of visual data, images and videos that we capture on every job site, together with predictive data analytics. That's the application of machine learning, artificial intelligence, to see how we can transform the way we practice construction project controls. Last few years have been really exciting years for construction. The value put in place in the United States has exceeded $1.1 trillion. This is the highest number that we've seen over the past 11 years. This status is not limited to the US. It's also happening globally, where the total value put in place in construction has now exceeded 13% gross domestic product when you look into the entire construction industry. Owners and contractors are identifying ways by which they can improve the way that they're delivering capital projects. We've seen a new trends of construction techniques, project delivery strategies, and also new processes and controls of how we manage safety, how we manage risk, and how we manage budget, scope, and schedule. While these are all very exciting status, the reports that are coming out from McKinsey and Company and a few other agencies are showing a very alarming status in our industry. Their report shows that the growth in productivity in construction over the past 20 years has remained relatively close to only 1%. While looking to industries beyond construction, that number is close to about 3%. So this gap between 1% and 3% represents a little bit over $1.6 trillion. That number is larger than the value that we put in place in the US every year. So as you can see, there's a huge room for improving productivity in construction. But what does it really mean to those of us who are in construction? That means a lot of our projects are finishing behind the schedule, and they're actually over budget. ENR, Engineering News Record magazine, published an article last year that shows their analysis that most typical projects, in fact, more than 50% of our projects, are behind the schedule and are over budget. Even in those cases that we are adopting lean construction practices, that we're trying to bring more project management techniques, we still see a large percentage of our projects that are behind the schedule. Another report that actually came out recently from project controls domain that shows over the past 3 years only, more than 25% of the projects that we have only been able to come within 10% of our goals. So as you see, we have a huge gap in terms of how we plan projects versus how we actually have capability of executing these projects. Now, this is only from a construction perspective. If you start talking to owners, they see it from a completely different perspective. To them, there are a number of elements that are really important. Number one, making sure that the projects are actually on schedule. Number two, that the projects are actually on budget. This might actually surprise you, because you were probably expecting cost to be the most important factor to owners. You know, for cost, we have controlled strategies in our contracts that we can manage it. But when it comes to schedule, we don't have a lot of control on how we can make sure contractors can keep their promises and finish the project on time. So to better understand some of the root causes for these issues, I want to take you back to some of the basics that we follow on every construction site. We always start our projects with a plan, schedule in place. Then we go to the job site, start executing tasks. Then we hope that we would have inspectors on the job site, our field engineers, who can monitor what happens on a weekly basis, then take them into coordination meetings and adjust. Or if you're following lean construction practices, you would start with a master schedule. You engage your teams in a process that we call pool planning. Then we try to communicate that in form of what we call weekly work plans, communicate that schedule on a daily basis, and then take them into meetings, see what we've learned from our failures or success in the past, and use that as a basis of improving the future. So let's look into some of the issues that we have in this cycle. Number one issue that we have with the fact that our projects are behind the schedule and over budget is inadequate communication. How many of you walked into a job site and this is the first thing that you actually see in the room? Can you raise your hands? Wonderful. The problem that we are facing is the following. Today, owners, contractors, and subcontractors do not have the same understanding of how much progress is made on job sites on a daily basis. We wait for an entire week to go into a coordination meeting, and we don't trust the information we receive from them. We ask them to stand up and color code or write notes on our drawings to tell us how much progress has been made. So from the time that the problem happens to the time that the problem gets communicated to us, we've effectively lost 1 week of work. The problem doesn't stop there. Over the past 10 years, we've significantly enhanced our ability to plan and create the schedules. But when it comes to understanding how much work could be done on a daily basis, or how much work could be done on a weekly basis, there's a huge room for improvement. Here I'm showing you a lot of issues that we see on many of the job sites that we've been monitoring. Part of this has to do with the fact that the people that we engage in the process of planning are not the people who are on the site. So we always have a misconnection in terms of what really happens on the job site, and those people who actually try to come with a revision of the schedule so we can actually improve reliability of our execution. The last issue that we have is risk management. A lot of practices and metrics that we use in construction job sites are retroactive. For example, we use a concept called earned value, or we use percent plan complete. These are great metrics, but they're retroactive. They can only help us understand failures and success in the past. Instead, the metrics that we really need to be proactive. That means they should help us understand the risk in the future. So to address these issues, in my lab and now what we commercially offer, we've looked into emerging and existing data that are happening on our job sites. So from one side, we've tapped into building information modeling. I know Gustavo is offering a course on BIM. So what we've seen as an opportunity is the fact that these models are around every job site. What we want to do is to see if we can extend their application, use them as a baseline for constructability by tying them into our production schedule. So every day you would see what is expected to be done on the job site. On the other hand, we love to tap into visual data. By visual data, I'm referring to 6 kinds of visual data. On every job site, you can walk around the job site, use your smartphones and take photos. These days, we see professional photography companies that are showing up on job sites and taking thousands of photographs. Using time-lapse cameras are pretty common. We usually see 1 or 2 of these cameras. These days, it's also becoming common to use action cameras for us to walk around, videotape work locations. Drones over the past 2 years have far exceeded our expectation of adoption of technology. Actually, construction is the largest market for application of drones in the US. And we also see laser scanning devices that are dominantly used for quality control purposes. While all this data actually exists on our job sites, they're not actionable. They are not yet telling us how much work is happening on the job site, so they can use that as a feedback to our project schedule. So our point of departure, based on this workflow that I showed you from planning to monitoring and control, really lies into developing a visual production management system. This system lies into 3 capabilities. 1, we want to see if we can actually have an element of reality modeling and computing. That means you want to take your visual data, images and videos, and use that as a feedback to your project schedule. Second, we want to see if we can tap into BIM and your project schedule to create what we call a reliable plan, use that to communicate and coordinate tasks on the job site. And lastly, tap into artificial intelligence and machine learning to see if we can identify elements of risk proactively, bring that to project teams so they can tap off delays before they actually surface on the job site. So within this spectrum, we put together a new environment that we call it Visual Production Management System. This system takes your visual data, it automatically gives you a 3D model of the job site based on what exactly happens. It contrasts and overlays that with your BIM. Your BIM is actually tied into the project schedule. So for every day, we can show you what is expected to be done versus reality. And we can go ahead and color code that based on whether the tasks are on the schedule. That would be green. And if you're behind the schedule, we would simply color code them in red. Not only do we want to understand how progress is happening on the job site, we also want to understand risk in the future. So what we want to do is to see if we can automatically color code elements in our model that are at risk for potential delays in the future. So we can inform our project managers so they can take strategies that can bring the project back on time and on schedule. Ultimately, we want to take these models with the reports that we can generate into our weekly coordination meetings. But instead of the same process that we always follow, we want to see if we can tap into these progress reports, help use that visual model to bring attention of our teams, make sure they can tap into our productivity data, and understand risk as it applies to their projects. So I'm going to go ahead and break these 3 components by first addressing the reality modeling piece. And that's a process of taking advantage of these models. Over the past almost 7 years, we've been working on a number of algorithms that consume your images and videos and can automatically generate a model like the one that you see on the screen. This is actually a $750 million project in St. Louis, Missouri. This happens to be a high-res structure as part of a campus, and you see a three-dimensional model that's been automatically generated from photos. These photos are actually captured with a drone, so you can actually see a lawn mowing pattern. You can also see images that are captured on the site. We take these images, you place them into the system automatically processes them on the cloud, and it can automatically generate models. With a click at a given location, you can find that image. Now you can actually take people who are off-site, walk on the job site, click on any desired location and do angle measurement, linear measurement, area-based measurement, or track volumes. So again, taking your photos and videos, automatically transforming to models. Now, obviously, the project doesn't stop in one photography session, right? We keep making construction, so we need to keep documenting. As part of our algorithms, we've also worked on a concept we call 4D as-built models, 4D for 3D plus time. That means every often, depending on pace of construction, you can walk around the job site, use your phone, take photos. We automatically generate models, and we would automatically bring these models into alignment. So I'm taking you to May. Let's go all the way to June. Less number of photographs, but these models are automatically aligned. Let's go a little bit further to halfway June. Now I'm showing you July, August, late August, November, February, and probably this is the late snapshot that I have from the job site. So again, without using GPS, without using any location tracking, purely based on the content of the images, we want to see if we can generate these models. So how do we achieve this? I don't mean to get into a whole lot of technical details here, but I'm just going to give you a high-level overview of what happens. We're taking these images that are usually captured in orders of tens or hundreds of these photos. These photos actually have a number of overlaps. So let's say if you have image 1, image 2, all the way to image n. We use computer vision algorithms that have the capability of finding distinct visual features. We work on algorithms that can actually match them in a pairwise fashion, prune out the errors that we have using fundamental metrics, and we've used a number of optimization techniques as part of a technique that we call structure from motion that has the ability to generate 3D models. By no means I mean to get into the details of it. We have a number of publications in this space that anybody's interested can look into it. We've been able to prove that these algorithms, compared to the methods that are dominantly using computer vision, can actually achieve an order of magnitude faster performance. What it means is that we've actually applied it over the past few years to hundreds of job sites, and we've been able to demonstrate that our method is somewhere between 6 to 16 times faster based on the algorithms that we're using, and actually shows you less error if you decide not to use GPS and location tracking techniques. But we don't stop there. The whole goal of taking visual data and generating these models is to track progress. So our intent is to see if we can actually contrast our planned models versus reality. But before we do that, we need to bring these two models into alignment. The alignment can be completely automated if you're using survey control techniques. It can be also interactive based on the number of features that the user would establish. What it means is that for the first time, when you start using a system like this, a user would select a number of corresponding points between the model versus the reality on the job site. Then we would solve for this least square problem that you're seeing on the screen, and we would be able to bring BIM and point cloud into alignment. Once this is done, because all of our point clouds are automatically aligned, every point cloud that you have in the future will also be automatically aligned with respect to the first model that we started. So what does it mean? That means every single photograph you have on the job site is now automatically mapped into your BIM. So I'm showing you one of the photos. This photo is automatically augmented by the content of the BIM, and the colors in this case are showing you 3 different subcontractors. It shows, as of this date, what do we expect concrete strategies to be working on? What is their work location? What are the tasks? You see the steel contractor and also the contractor that is working on our curtain wall. Now, this applies to every single image. So you can use this for every bird eye view that you have on the top, your drone, any side view you capture, or even walk around with a smartphone and capture a lot of photographs. So I'm going to show you some examples. Let's imagine that we go in one of the site images and want to see the site. You can go into any image that you desire, be able to get access to the photograph, see the model overlaid on it, and the model carries the same colors. Now you can use the visual content for things beyond tracking progress. For example, you can use it for managing issues. By issues, I'm referring to RFIs, requests for information. I'm referring to your quality items, or even I'm referring to safety. You can pin various locations to minimize how much time you spend on coordinating these issues with different contractors, architects, and engineers on your job sites. You can simply mark up, and we have also capabilities of sharing these via text message. It actually works internationally, so even if you're in Mexico, you'll be able to take a screenshot of a system and a different location, put a number in it, and be able to share that with your project team. So all of this is obviously coming from a schedule. Over the past months, we've had the opportunity of joining Oracle. Oracle is a company that offers Primavera P6, the dominant scheduling solution, and we've been the first startup company that's been accepted to their scale-up. What it means is that we will tap into the same schedule that construction companies have. We bring that into alignment with our model, so now you would see the same model with same colors that you see reflected in the schedule. So every day you can see who is expected to do what work in what location, and you can contrast that to the reality. Because we take advantage of BIM, we can automatically extract quantities. So we can benchmark how much work is expected to be done, use that as a basis of BIM-based tracking of progress. We can also organize your task in form of workflows. What are the tasks that are happening across locations? Show the tasks that every company is doing across different locations, and use that as a strategy for your superintendents to more proactively manage projects. Obviously, this is a holy grail that we want to get into. We've been able to bring BIM and reality into alignment, so I want to see if we can color code locations as to whether on schedule or behind the schedule. So now I'm going to get into a little bit more technical detail. We wanted to do this automatically, so naturally the question that we wanted to ask was, how can we automatically compare our point clouds against BIM? The first thing that comes to all of our minds as civil engineers is to tap into geometry. So we started working on a number of machine learning algorithms. Imagine that you're looking at the building from the top. So this is a plan view. What you see in green happens to be the building walls. We've actually quantized this scene into voxels, and we reason about occupancy and visibility of these scenes by back projecting our BIM into our images. And again, I don't mean to get into formulations and details here, but we use a number of machine learning techniques to be able to understand what is the expected visibility of every element versus the reality of it. Put it into this machine learning algorithm, train a hyperplane that can tell us if the element is on schedule or not. This is actually a paper that we published in a computer vision conference, and out of this work, we are able to show that accuracy of our detection, automated detection, is somewhere between 80 to 90%. Now, these numbers may look great to you, and you say, well, this is a good starting point. Well, what are the challenges you have? I want to show you two types of error. When you use geometry, the system can actually make mistakes in recognizing construction components. I want to show you an example of a false positive. Our system was purely reasoning about geometry. So it looked into that concrete wall. That piece is under construction, right? You see formwork. The system automatically color-coded that in green because it doesn't have ability to differentiate between concrete versus formwork, between reinforcement bars. Here's a second example. It's a false negative. We had limited visibility to that element. So when the system was making an assessment of how much progress is made, it made an error, and it obviously color-coded the element in red. So once we were able to accomplish geometry, the second natural question for us was, can we tap into the content of the images that we have and see if we can automatically contrast and identify construction materials? So what do I mean by that? Imagine you have a picture like this. We want to see if we can automatically identify concrete versus waterproofing versus insulation. Not only automatically detect that, but use that to infer the status of the progress. But we have two problems. One, this requires us to understand means and method of construction and formalize these techniques. This might surprise you, but after these many years that we've been practicing and teaching construction, we haven't yet formalized these techniques. So we started looking to that as a starting point. The second issue has to do with BIM. When we look into BIM, a lot of the models that we receive are usually design models. These models only stay at what we call level of development, or LOD 300 to 400. That means they don't reflect shop drawings, what we actually build on the job site. The second challenge is the schedule. A lot of our contractors create master schedules without exposing really the details that are necessary for progress tracking. So we don't understand what is the expected material that we need to be recognizing for every given component. So to address this issue, we can build on the previous work that we had, and we came up with a very simple concept. Now we have our images aligned with BIM. why don't we automatically back project our BIM into the same views that we have for images? Go ahead and extract relevant parts of the image. So for example, you're looking at an element number 99. This is our camera number 5 out of 100 images that we have. This is element 112. And do the same for the content of the visual data you have. Now the question becomes more simple. We want to see, by looking at the image patch here, would you be able to automatically recognize that you're looking at concrete? Now, we had a opportunity here. The fact that we actually have tens or hundreds of these photos. What that means is that probably every single element that you're looking at will be visible from multiple photographs. So one element that you're looking at can be back projected into 4 photos, so you can make your recognition 4 times. So as part of that, we decided to take strategy of back projecting every image patch, extract square-shaped images, and now your problem is, can you take any of these image patches, feed that into a material recognition algorithm, and tell us whether you're looking at concrete versus you're looking at insulation versus you're looking at formboard. And then we understand that some of these techniques that we would have will not have a perfect performance, so we want to tap into frequency of observation. Whatever material has been most frequently observed is the one that we're going to be recognizing. Again, I don't mean to get into details. This is a paper that we published in Computer Vision and Pattern Recognition Conference last year. It taps into a technique called deep learning. And the basics behind it is really simple. We're looking to texture, we're looking to color, and we're looking to the geometry of the scene, and we see if we can dynamically learn models that can differentiate construction materials. So if you're interested in tapping into this work, for the first time, we've publicly released a data set that's been captured over 3 years on tens of job sites that would give you access to photographs of 20 construction materials. These photos have actually been captured from various viewpoints. They actually show you different kinds of construction material, and even the code that you may be wanting to use for your computer programming is also being provided to you. But what does it really mean in terms of performance? We've brought that back into our construction material recognition, and now we've shown that we have the ability to even improve further our ability to very accurately identify state of progress automatically. So an average of 4 different case studies that we've done here shows the number is closer to about 90%. But we didn't want to stop here. Naturally, when you have photographs, you would always have a number of elements that would not be fully visible to you. You would look into a column, you would look into a wall, you would only see one side of it, or maybe in part of it is being occluded. So we actually tap into some basic knowledge that we've had in construction. We always follow certain formal sequences in our construction. For example, if you're looking at this foundation column, foundation wall over here, for example, you would see that the wall or the column would be supported by a foundation. So if you have ability to automatically recognize that column, because the relationship between these components are supported by, maybe you can also make an inference that obviously the footing should have already been constructed and in place. So we wanted to tap into this. We looked back into some classic work that was actually done at the University of Illinois back in 1991. Diego Echeverri, who was actually at Monterey Tech for a number of years, with Bill Ebbs that currently is at UC Berkeley. And they actually formalized a sequence of relationship between construction activities in terms of activities that are supporting one another, elements that are being embedded into the others, elements that are being attached, with the goal of using that to better infer automated tracking of progress. Then we tapped into BIM. For those of you who might be familiar with BIM, we're looking to what we call IFC, Industry Foundation Class Representation, see if we can automatically reason about these relationships from our models, and we bring that into alignment. So we are actually showing a rather newer paper that we have that if you also tap into these formal knowledge of sequencing and a reasoning-based method on construction, you can actually even further your capabilities of detection by another 5 to 6%. Now you're getting to a range that automated progress tracking makes sense, and construction companies can start using them. So what does it all mean? Now we can give you a timeline that would be automatically color-coded, a timeline that will show you what is happening right now visually, so everybody would be able to understand, and a timeline that is actionable, because you don't have to wait for an entire week to really understand what is happening on your site. Now I want to take you to the next step. Obviously, we didn't stop here. We want to see if we can proactively identify risk in the future. So when actually Gustavo was spending his time at the University of Illinois, we initiated another opportunity, which was how do we transform our practices today that are retroactive and develop new metrics for tracking progress that can identify risk in the future. And as part of that, for the first time, we are introducing a new metric that we call it task condition readiness. how ready a task is to start on time in the future. So how can we predict reliability and readiness of tasks in the future? It's really a function of three things. We try to track progress and productivity of every trade. We try to learn that over the execution of the project, and we're looking to reliability of them responding to your RFIs, quality issues, safety issues, and even being able to satisfy their own requirements. By tapping into that, we've been able to create a number of reports that can now tell you what are the top locations that you have on the job site that are at risk for potential delays. Again, we can simply color code them, and we can show you where you need to pay your attention to so you can actually address issues. For executives that are on job sites, this all means that you can provide them with a dashboard. This is actually a report that we've created for a construction company that we engaged in that shows you the trend of performance over a number of weeks. We can automatically give you an understanding of volumes of work that are being planned, snapshot of the performance across companies, and look at root causes for delays. What are the issues that are causing your project not to be on schedule or on budget? Now, a lot of job sites, while technology is exciting, you always have people that still want to rely on old-fashioned ways of interacting with data. So we've also created mechanisms that can push out spreadsheet views where you can simply show % progress in a form factor that every foreman, every subcontractor that may not be tech savvy would still be able to use your predictive data analytics. Lastly, we can offer you productivity rates that are organized based on trades, companies, and locations. And finally, we can bring them into coordination meetings. So here, the idea is really simple. The idea is to see how we can transform today's practice that we usually start a meeting by touching on safety items, then we touch on quality items, then we go one company at a time around the room, trying to engage them in a conversation. Here, we're trying to bring attention to risk. So as you see, the superintendent is highlighting 5 locations that are automatically marked for him as risk, and he's trying to engage all of the trades in a conversation about risk at that location. Immediately, a few contractors are being impacted. Not only it's about collaboration, but the fact that it's also about the future would provide more incentives for them to give you input that can help improve the reliability of plans. So we've done 2 things. We've transformed the practice of being retroactive in our project controls to be proactive. Second, instead of focusing on tasks and singling out one company at a time, we try to go location at a time so we can invite them to collaborate with one another. Now, we had the opportunity of actually benchmarking the impact of this system to a case study. So we got engaged in a project. Over a few weeks, we tracked their performance using 3 metrics. % plan complete, how much work gets done on this job site. That number was a low of 46%. We're looking to how many times tasks are being delayed or how many times tasks are being repeated on the job site. And over 6 weeks of our engagement, we're able to show them by tapping into visual production model, you can improve how you communicate and coordinate your schedule. And that means you can actually get into numbers that are more reasonable in terms of your performance and less number of times tasks are being delayed or repeated. So you may say, how exactly was this achieved? What are the root causes that this team was not able to achieve, and how are you able to transform it? So let me touch on that really quick here for you. Number one issue that this team was facing was actually very frequent changes in work plan. We started attending their meetings. We recognized that every week you go into a meeting, you would see that these plans are dynamically being changed. So now the fact that the superintendent had access to reports about risk was providing him with actionable data that he can bring attention to locations that actually matter, and he was able to generate more reliable plans to improve the future. The second item that we touched on was the fact that subcontractors were showing up on the job site and locations were simply not available to them, or the handoffs was not being completed. The system actually shows you who does what work in what location every day. So you'll be able to use that to provide real-time knowledge of what are the tasks that are being complete, what are the workspaces that might be available, and if you want to take the further step of providing them with a backlog of tasks, now they know if they walk into a work location and that location is occupied, what are the other opportunities that they have that they can maximize their own productivity and improve the overall performance of the project. And the last issue that we very frequently see, at least in the US, in many of our job sites, is underestimated effort, productivity. The fact that the system can provide you with productivity data can help you better gauge data and use that as a basis of creating more reliable plans. So with these 3 simple techniques, we're able to achieve a better way of coordinating and communicating that schedule. Now you may say, what happens indoors? Drones are great. You can take photos from outdoors, but what happens if you walk indoors? we use a number of strategies for mapping indoors. One strategy we have is to tap into what we call 360 images and videos. How many of you have seen cameras that do 360 photos and videos? Or maybe you've seen them on Facebook, right? So the idea is to take many of these images, automatically place them into structure for motion algorithm, and now you can transition between these images automatically, and you have the geometry of it in the back of it. So you see there's a point cloud in the back. On purpose, I'm showing you a really poor resolution video to show you that it really doesn't matter what you have on the job site. As long as your visual data have overlap, we will be able to use that to generate a model like the one that you see on the screen. Say, what about the other modes of capture? So I want to touch on iPhone or smartphone-based capture. You can also walk around with your phone, take photos that have overlap, and now we can give you transitions between photos automatically. So all these photos are mapped without using any GPS, without using any location, and give you ability to perform monitoring. Here's an example of laser scanning. So we can also use that and bring that into alignment. And this is an example of what we call an RGB plus D. R for red, G for green, B for blue, plus D depth. It's a different type of camera that can actually provide you with very high fidelity of view. So we want to see if we can tap into all these kinds of visual data for mapping indoor environments. Now, for some of the job sites that may not be interested to take these many photos that we need, we also offer a different strategy, which is helping them with hotspots that are marked on 2D drawings, let them walk around the job site, take photos, videos, or 360 photos, and we even also taken one further step, which is auto voice transcription capability. You take a photo, you directly talk to the app, our machine learning algorithm would automatically transcribe your voice into text. Actually works in the Spanish too. When we started working on this, it may surprise you. Turner Construction, the largest construction management company in the US, and DPR, a rather leading company from the West Coast, they approached us and said, what if you try to automate the process of data capture? So we put together a team at the University of Illinois, and this is a prototype. So this is not yet a solution that we commercially offer. We created a new ground robot, not the hardware of it, but rather the operating system, that is operated manually for the first time by a superintendent. You see there's a device sitting in front of it. That device does a visual capture of the scene. We would automatically learn the map, and this robot can follow the map over and over automatically for you. So you'll be able to capture the same floor over and over. If you're doing drywall construction, if you're doing installation of mechanical, electrical, and plumbing component, you can let the robot, like Roomba, walk around the room and do the capture. How many of you have seen Roomba, the robot that goes around and does the vacuum cleaning? So that's the same concept. A robot that walks around the job site does your inspection for you. Now, again, I'm just touching on a few other items that we've also done. As part of our work, one of the other questions that was being asked was, how do you guarantee completeness? Today, a lot of job sites, we want to hire drone operators. Especially in the US, we have regulations by Federal Aviation Administration that would enforce you to have somebody preserve line of sight. And that means for every capture, we have to spend hundreds of dollars to bring somebody on the job site, fly the drone for us. So how do we guarantee that this person who shows up on the job site would actually be able to achieve accuracy and completeness of the capture? Are there techniques that we can create to guarantee that? So what are the two problems? Often when we go on the job site and do these captures, we end up coming back realizing that there are holes in our models. We don't have time to go back and capture them. Or we generate models, our algorithms fail in finding the optimal point, so they get stuck in local minima and they generate a drift. So I wanted to see how we can dynamically address these issues before we actually go into the job site. So as part of that, we have a very recent publication that taps into the idea of verifying flight plans in 3D. It starts with a very simple interface. You open up your iPad. This applies both to your drones and ground robots. You say, this is a building that I want to map. These are the locations that I deem unsafe, so I want to geofence them out. Automatically give me a three-dimensional flight plan. We do that. Then we bring BIM for you. Then we can make an assessment on safety of moving that ground robot or the drone. Also, redundancy in visibility. How many images do you really want to capture? How many pixels you want to have per element? So we can automatically color code elements in the model before you take your drone out. And we can guarantee by modifying your flight plan that once this drone operator shows up on the job site, you can guarantee that capture. So everything I've shown you so far has been more focused on progress tracking. I touched on a few techniques that would give you reality models. I touched on 4D BIM, how it gets integrated. I showed you a number of techniques on progress tracking. But what about this wealth of visual data that we capture in form of videos? What are the other things we can do with them? So naturally, some of the questions that we wanted to ask was, can we detect our resources? Can we detect our workers? Can we detect our equipment? And can we detect our materials? So again, I don't want to get into the details of it, but now we have algorithms that can detect and track workers in real time. This is 10 frames per second. That's the fixed camera you see on the left side. And this is an iPhone recorded video on the right side. Every single box you see here has been automatically mapped on the workers. The numbers that you see on the top are showing reliability of our algorithm in detecting that the object of interest happens to be a worker. So now you get a lot of imagination. You can start using this for safety. You can think about the implications of this for productivity and the interface between the two. So naturally, when we demonstrated this to some of our industry partners, one of them, Turner Construction, said, can you help us detect workers that they don't have safety vests and hard hats? So we actually developed an algorithm, which is what you would see in that little video over here. The moments that the workers don't have safety vests and hard hat, there will be a red box that will be indicating these workers. Because we actually have geometry of the scene, we can also map location of the workers. We can show you X, Y, Z, where these workers are located, so your safety engineers can log into a system and say, I see an opening, right? Can you measure exposure of my workers to this safety hazard? Can you give me spaghetti maps of that? So another element of that. Lately, we've even pushed the bar a little bit further. Purely based on a video camera, we want to see if we can automatically detect your body skeleton. Again, I don't mean to get into any of the details of the algorithms. We'd be happy to send you the papers. But the idea is very simple. See if you can actually learn models that would characterize the body posture and in real time give you ideas about performance on the job site. So what are the implications? Obviously insurance, right? Ergonomics. You want to see what are the opportunities you can use to understand body posture throughout the day. And maybe also productivity. Again, I don't mean to get into details of it. Here's an example of one of those algorithms that we've recently published. But once we did this work, equipment manufacturers actually approached us. The number one was Caterpillar. Caterpillar happens to be local to us in Illinois, so they asked us whether we can apply this technology to construction equipment. So what does it mean? They wanted to see if we can detect, track their equipment live, automatically recognize the activities that they perform. These are two different sites. They're actually mining sites. On the left side, you see CAT versus CAD. Over here, you see CAD versus a Komatsu machine. So you may say, well, wait a minute. Caterpillar sells us telematics equipment. How many of you know what telematics is? It's a piece of device you put on your construction equipment, so it provides you with information about the health of the equipment. It's pretty expensive. It usually costs somewhere between $50,000 to $120,000 per telematics device, right? And Caterpillar loves to sell every contractor in the world one of these telematic devices per machine. But here's the challenge. No owners buy all their equipment from the same vendor. On purpose, when you go out and buy, you buy mixed fleet. You buy it from CAD, you buy it from Komatsu, you buy it from Volvo. So the idea we had was to see if we can use videos to automatically recognize not only how CAD equipment perform, but rather how the competitor equipment is performing, and be able to use that information to understand how much time is being spent on idle versus digging, how much time is being spent on the equipment swinging, how much is moving. Now you have actionable data that the construction equipment operator can use to improve performance of the construction equipment. Obviously, the natural question was, can you also do this for workers? The challenge is, we don't yet have good data to achieve this fully automatically. But here's the concept. We can automatically identify roles of the workers for you, body posture, tools they're using, and sequence of construction activities. So at the bottom of the screen, you see what we call a crew balance chart. Every minute shows you what are the activities that every single worker in the video is performing. So if you're a contractor, you simply upload a video. You do what we call a first run study, analyze sequence of, let's say, concrete placement, and see what you can get from it. So let me see if I can actually advance this a little bit further. It gives you a bar chart that shows you what is the sequence of activities that are being performed. And now I can also give you a pie chart. I can show you what percentage of the time is direct work, how much time was spent on waiting for materials, how much time was being spent on traveling because maybe resources are too far from you, and how much time is being spent on tools and equipment. Now you immediately get an idea. These guys are placing concrete. They're using a bucket and a tower crane. What if we change that with a palm and start bringing, chutes to place the concrete? Is that going to be a number that we're going to be looking at? So immediately you empower foremen and the workers with the information that they can use to maximize their productivity. I want to go back a limit for a moment. I want to touch on the number. Maybe I can pause here. The number that you see here is 59% productive work. What do you feel about it? Is this a good trade? Is this a good crew that you're monitoring, or is it a bad trade? It's actually a very good crew. Most of the job sites, when we monitor their activities, we see that out of every hour, at best we can get somewhere about 25 minutes direct work. The rest of it is the time that we're spending on coordinating tasks, right? So this is an example of a really good crew. So the idea, again, is to empower workers with the information that they can use to improve their own productivity. So now I've shown you these works. I really want to summarize everything I presented you with a few takeaways. I've just shown you how you can tap into your existing visual data, images, videos you have, plus BIM, to improve how we do planning, because now you have actionable data on progress, productivity, and risk, how we can better coordinate the schedule visually, and how we can streamline our communication on and off site. So a number of benefits you would immediately get from it. Number one is transparent process view. Everyone on job sites understands visuals. You don't need to spend time explaining people what they see in a photograph. So you can actually use that as an opportunity to eliminate problems in the future. We can proactively highlight things that are at risk for delays. I showed you with the statistics that in projects that we've been engaged in, you can maximize your own performance by an order of magnitude by tapping into this visual production management strategy. If you tap into the elements of detecting and tracking workers, you can look into better planning of your personnel and logistics in terms of how we manage our job site, what are the resources that we need, and whatnot. Streamline billing. I think this is an actually element that probably applies to a lot of contractors in Mexico. My understanding is that on every job site you have surveyors that walk around the job sites. They have to monitor what happens and use that to verify how much you have to pay contractors, right? Now you can actually go into the system. You can click on any desired work. You see what the schedule dictates. You find the photograph. So you can visually verify that billing, and you can streamline that process. Today, every subcontractor in the US is being delayed by almost 2 to 3 months on their payments. That's the average nationally. So you can actually minimize that time spent. And that's why we've actually partnered with Oracle to see how we can integrate it with a platform called Textura, which is being used for managing payment applications. I think you can immediately see the elements of quality control. The moment that you have reality versus BIM, you can contrast the two and measure flatness, plumbness, looking into deviations. And safety. Everything I've showed you with respect to videos can help you have intelligent information that you'll be able to tap into safety. All in all, it really gives you an opportunity to provide a win-win situation for every party. Owner understands how much work gets done, contractors get understanding of how much work is being done, and subs have information that they can use every day to be able to improve their own productivity. So that being said, I want to quickly acknowledge the people who have actually sponsored this work. Majority of the funding for this work comes from National Science Foundation through a number of grants from National Robotics Institute, Cyber Physical Systems, Civil and Manufacturing, and Innovation Team. And a lot of other companies. Hardware behind the work comes from Intel, NVIDIA. Funding comes from Caterpillar, Fiatech, Construction Industry Institute, American Association of Railroads. I didn't show you what we do in the railroad business. O'Hare Airport, for those of you who've traveled. We've done a number of works for the airport. And a number of other agencies, construction companies that have actually provided us with funding resources that we need to do the work. Obviously, we need a lot of data. We need images, videos, and we need BIM. That cannot happen unless if you start collaborating with companies. Here's just a brief list of some of the companies that over the past 5-6 years have been graciously helping us capture data, mostly in the US, but you will see also a number of companies that are working internationally in several different locations. Lastly, all of this work is not me. I'm just standing here and presenting this work to you, but there's an amazing team of people who've been working on it, including some of which who've actually graduated. Professor Yanji Pam, who's now at Texas A&M, Joe DeGaulle, he's Microsoft researcher, Vahid at California State, Kevin at North Carolina State University, Arsalan at University of Virginia, and obviously Gustavo, who's here, and the rest of the amazing team who's behind the work. Having said that, I want to thank you for your attention, and I want to see if you have any questions for me. Thank you.
Thank you very much, Manny. Ahora vamos a pasar con las preguntas, levantando la mano y nos van a ayudar para acercarles el micrófono. El primer valiente. Héctor.
Yeah, thanks. Thanks, Manny, for your presentation. I just have a question regarding the quality control. You mentioned, well, we can use it when we compare with the bin model, but I was wondering what is the level of precision that you can get from the model? I don't know, for instance, if you're comparing like the location of a plate, or if you want to, I don't know, take into consideration the if a weldment was done correctly, or if an embedment was placed correctly.
That's an excellent question. So quality control, I would use the word precision and resolution to explain accuracy. There are two elements to that. One is the process of capture. Usually the best visual capture device to use is a laser scanning device. Most of the laser scanning device can actually give you almost millimeter level precision. When I speak about millimeter level precision, I'm referring to laser scanning devices that cost close to about $100,000 to $200,000. That's the cost today. There's an element of having two field engineers operate these devices, but it can actually give you enough precision that you can use it to even measure flatness. And there are a number of commercially available solutions that do that. The second part of your question has to do with the contrast with the model. That really relies on level of development in the model. Ideally, your model should be at the shop drawing level. That means for your structural component, MEP, ideally we would see LOD 400 level for these disciplines. Then you can take a base plate, then you can look into reinforcement bars and use them to contrast. I want to give you an example of what you can also do with photogrammetry. I think it was about 6 years ago that we partnered with National Institute of Standard and Technology in the US, the agency that establishes the standards. And there's a publication that's been nationally published. They're looking into contrasting laser scanning versus photogrammetry for automatically checking reinforcement bars prior to placement of concrete. So before you place concrete, you lay out the rebar mesh, right? You have pipes, you have conduits, you have openings. You want to go out and quickly verify to make sure everything is in place, create a visual record, and so you can come back and make sure everything is in place. We've actually been able to achieve 0.5 millimeter level precisions with that technique that we have. But it really requires precision capture. And precision capture is not easy. If you actually tap into any of these robotics elements that I mentioned, then you can actually get into these levels, but practically it's hard to achieve. It can be limited to your special projects, special locations, but that's something that has been achieved in a number of ways. I have not worked in the area of plumbness and flatness. There are a number of publications and commercially available solutions. If you're interested, I'd be happy to share them with you. But these are things that I know companies like DPR, Walsh, and also Turner practice them on a weekly basis. Thank you. Other questions? Anybody scared about the video detecting and tracking workers? Questions?
¿Alguien más?
Yes.
I'm actually really excited about the safety aspect and tracking the workers. Having worked in construction, having worked in construction, I've seen accidents. I've seen many accidents. I've seen from the Dallas-Fort Worth, Texas area, a lot of heat, humidity, where we have heat injuries, heat stroke, and I lost a good friend to heat stroke. I've had situations where I've had workers where they didn't realize what was happening to them. And I see that data capture being a tremendous resource. Can you speak at all to what future you see in that? Do you see other technology that's coming that will be able to help you with that?
That's a really good question. So the question is, what are the other technologies that can potentially help with the process of detecting and alarming for safety on job sites? From a research perspective, over the past, I'd say 5 to 6 years, we've seen a number of work that is being done on using location tracking technologies for identifying location and body posture of the workers. I want to give you a few examples. GPS is an obvious one, but now the fact that workers have smartphones, you want to see if you can tap into their existing smartphones and triangulate their location as a function of not only GPS, but proximity of other smartphones to that. The second one is using ultra-wideband that requires you to place a number of nodes in a building, or even using Bluetooth technology for triangulating location of workers. These days there are elements of Bluetooth that you can actually place into your LED lights. There are some manufacturers that actually offer you, which would triangulate your location. But the challenge with all of these technologies is that you need that infrastructure to be in place before you start tracking. So the number of software and hardware companies that are offering technologies today. I want to name one, Triax. is the company has been recently bringing new sensors that you can mount on the body of the workers. They have the ability to track your location as a function of the day, and I know they have other elements of sensors, including measuring body temperature and humidity that have been looking into it. I've also seen work that other startup companies like Rhombix are doing out of California. What they do is they're looking to sensory data on your smartphone, which includes your GPS, pressure data, accelerometer, and gyroscope, using machine learning techniques to see if they can automatically figure out the activities that the worker performs. I have seen them using it on a few job sites with the Skanska and I believe the DPR, and maybe Bechtel. Maybe it was actually Bechtel. But I've not seen that scale yet. But I'm very optimistic that in the next few years you would see more of these technologies to be used. The challenge is, I think, more about the process and organizational changes. Because there's always an element of educating workers that, ultimately this is all about safety and helping them maximize their own performance, as opposed to trying to find out the slack worker. That's an excellent point. Other questions? How many of you have operated drones here? Anyone? All right, now you can actually tap into your visual data for any job site you're on. You're taking photos, you'll be able to start tracking your progress, and we'd be happy to work with you on this.
Thank you very much, Manny, for being here. I guess if someone else has any questions later, you can address them during the break.
Absolutely, I'd be happy to.
Muchas gracias, Manny. Quisiéramos poder continuar despejando todas las inquietudes. Sin embargo, el tiempo es corto. A continuación, haremos entrega de un pequeño reconocimiento en agradecimiento por tan brillante conferencia.
Thank you so much. Thank you, appreciate it. Thank you very much. Thank you very much. Should be taking some photos. Right? So this thing, here, over here, or sure. Thank you. Thank you. Thank you. Thank you. Thank you. Appreciate it. Thank you.
Agradecemos profundamente al Dr. Manny Golparvar por honrarnos con su valiosa presencia y por compartir con nosotros tan enriquecedora conferencia. Concluimos de esta forma el primer día de nuestro ciclo de conferencias. Les agradecemos su presencia y los esperamos el día de mañana a las 10 de la mañana para comenzar puntualmente con la conferencia Agua, Fuente de Vida, Plantas de Tratamiento, por parte del ingeniero Cuauhtémoc Corona. Muchas gracias y que tengan buena noche.
Appreciate having me.
No, gracias.
Thank you.
Very
I hope you
nice.
enjoyed it.
Very important.
Thank you.
Very important.
Sure. You take a photo? Yeah. See you.